All right. So, remember the formula. The formula for geometric sequence. A to the n equals a to the 1, r to the n minus 1. So we need to calculate some things. Well, one, we need the first term. In this situation, they're giving us the first term. In this one. Yeah, what's the first term in the sequence? 8. So we got the 8. Now we need r. This is a case where they're giving you consecutive terms. All right, they're giving you consecutive terms. So you can take any two consecutive terms and you take the second one and put it over the first one. That is your r. All right, now for this one, I would do 8 and 6 because they're both integer values. If we compare 8 to 6, which one comes second in the sequence? 6. Which one comes first? 8. Your only responsibility is reducing that. 6 over 8 reduces down to what? 3/4. All right? So that means this becomes 8 times 3/4 to the n minus 1. Now, first thing it asks for is the next two terms. So all I'm going to do is take each term, or the last term they give me, and multiply by what fraction? 3/4. So I go to my calculator. 3 plus 3 divided by 8. Everybody okay with that? And then I multiply by 3/4. And it gives me that decimal. If you really want to write out that decimal, okay. All right, but what I would prefer that you do is say math and then what button? 1. And then it'll shoot it out for you, 81 over 32. So the next term is 81 over 32. Now, if I'm multiplying by 3/4, can I just multiply the numerator by 3, the denominator by 4? Yeah. 81 times 3 is 243. 32 times 4 is 128. So that's how we get the next two terms. Then the last part of the problem asks to get to what? To 100. So I go to my calculator, and now I'm going to use the formula. All right? So I go back to my formula that I configured, the 8 times 3/4 to the n minus 1. Well, if I want to get the 100th term, what do I replace n with? 100. So I'm going to do 100 minus 1, which is what? 99. So I go to my calculator, and I do 8 times 3/4 to the 99. And you're going to get a number in scientific notation because it's very, very small. All I would expect you to do is write the first couple digits. And that would be 3.42. And then write it correctly in scientific notation, 10 to the negative 12. So that's all I would want you to do. All good? Now, the next one is the trickiest of all these to do. It says the fourth term of a geometric sequence is 125, and the 10th term is 125 over 64. Find the 14th term. So these two problems are exactly the same. All right? So here's what we're going to do. First off, we are going to take the later term, which is 125 over 64, and put it over the earlier term, which is 125. Does that make sense? So whatever comes later goes on top, whatever comes earlier goes on bottom. Then you're going to divide. 125 divided by 64 divided by 125, math 1. And you get 1 over 64.
Excuse me, at the end of the period, can you have page period come to the office 1112?
Absolutely.
Thank you.
You're welcome. All right. So that comes out to be 1 over 64. I'm then going to set that equal to. I'm then going to set that equal to the difference between the terms as an exponent of x. So when I say the difference between the terms, this is the what term? Tenth. This is the what term? Fourth. I just subtract bigger number minus smaller number. What's 10 minus 4? 6. So x to the 6th equals 1 over 64. Now, in case you don't remember this, Victor, in case you don't remember this, alright, when we're solving an equation with an exponent, we're going to do roots. The inverse of 6, or the reciprocal of 6, is 1 over 6. So we're going to raise that number to 1 over whatever the exponent is. So I'm going to go to my calculator and I'm going to do 1 over 64. I'm going to hit the exponent button and I'm going to enter 1 divided by 6. One divided by 64. 1 divided by 6. And I get 0.5. That, ladies and gentlemen, is your R. That, ladies and gentlemen, is your R. Later term over earlier term, you get your quotient. Set that equal to the x to the difference between the terms. Solve by doing the reciprocal. Hopefully you learned last year, rational exponents is the same as turning them into roots. And whatever the denominator is your root. Make sense? Now, they want the 14th term. They want the 14th term. 1, 2, 3, 4 is 125. So we discussed yesterday with geometric sequences, we multiply by r, which would be 1/2 going that way. So just like arithmetic sequences, to get a to the 1, we're going to work backwards. So what's the opposite of multiplying by 1/2? Multiplying by what? 2 over 1. What's 125 times 2? 250. What's 250 times 2? 500. What's 500 times 2? What's a to the 1 according to simple mathematical computations? 1,000. So again, if I want a to the n equals a to the 1, r to the n minus 1, what term are they asking for? 14. A to the 14 equals a to the 1, which we computed to be what? 1,000. And if I plug in 14 to n minus 1, what's 14 minus 1? 13. And then what in the initial part of the process do we calculate r to be? 0.5. I go to my calculator. I do 1,000 times 0.5 or 1/2 to the 13th power, and I get that long decimal. As we discussed yesterday, the only thing I'd ask you to do at that point is hit what 2 buttons? Math and 1, and see if it simplifies, which it does. So your final answer for that would be 125 over 1,024. Before moving forward, Is there any parts of that process that seems bewildering, befuddling, unclear to you? This is what I would expect to see for work. That, and then the result for this, and then the plugging in here. Does that make sense? So that's enough work for me to make sure I understand what you're doing. Does that clarify or no? Good. Because this shows you're understanding the first part and getting R. And if you do the rest like in the calculator, I'm fine with it. This shows you understand how to plug it in. You know what I mean? And then you're fine with it. This isn't on Friday's test. Tomorrow's test is all conics. It's all graphs. This is for when we come back from our little siesta next week. So this is not on tomorrow's test at all. You'll probably have a quiz on this. We'll do one more unit, and then you'll have your last test. Then we'll start working on the final unit. Everybody's good with that part of the process? All right. So let's talk about the sums of geometric series. We start with finite. The sum of a finite sequence with a common ratio r not equal to 1 is given by the formula S of n. Summation equals a to the 1 times 1 minus r to the n over 1 minus r. So we need the first term. We need r, we need how many terms there are, and we're just going to simply plug into that formula. So I look at my problem, and it says this. What decimal is being raised to the exponent? 0.3. That's your r. Make sense? You need n. When this is 1, when that's 1, then n is your top number, which in this case is what? 12. So this would become a to the 1, which is 4. All right. Parentheses, 1 minus 0.3 to the 12th. Over 1 minus 0.3. What's up?
Could you write it as like 1 minus 0.3, 12 minus 1?
You would get the inverse of it, negative. You say 0.03 to the 12th minus 1?
12 minus 1 is the same thing.
The exponent, you got to remember order of operations.
Oh, yeah.
So we have to simplify inside parentheses first. So basically what we're going to do is, so in other words, what I would do is I'd go right to my calculator. So this is exactly how I would compute it. All right? I would do the 1 minus 0.03 to the 12th. All right? So 1 minus 0.03 to the 12th. I would do that first. Gives you that, which I get. All right? Divided by parentheses 1 minus, 1 minus 0.3 to the 12th. Gives me that. That's the numerator. Divided by parentheses, what? 1 minus 0.3. And then what's the number on the outside we've got to multiply by? 4. We have 5.71. Again, what I would then expect you to do is hit math and what? 1, and it's going to shoot out the same decimal. So you would approximate that.
So for the first part, like where the 1 minus 0.3 is,
Right. I would leave in the calculator like that for exactness. Apparently I'm now flipping. That was weird. Good? Everybody good? Now, if this isn't 1, if that wasn't 1, so let's give an example. So let's say they say I equals 6, and this is 50. If you had something like that, so you get where I'm at? So if that's not 1, all right, to get n, just subtract the two numbers and then add 1 at the end.
So in other words, what's 50 minus 6? 44. 44 plus 1 is 45.
If I is 1, you can just grab the top number. If I is not 1, or the bottom number is not 1, then you have to subtract and add 1. Seem good? All right, last thing in this part of the unit. Geometric series, the sum of the terms of an infinite geometric sequence. If the absolute value of r is less than 1, then the infinite geometric series a to the 1 plus a to the 1r plus a to the 1r squared plus dot 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 plus a to the 1r to the n minus 1 has the sum s of n equals I equals 0 to infinity a to the 1 over 1 minus r. Find the sum of the geometric series 5 plus 1 plus 0.2 plus 0.04 plus dot dot dot. All right, so why is 5 important? Say to the 1.
So your first term, if they give it to you, is a to the 1.
Now, I'm then going to do 1 divided by 5.
Why am I going to do 1 divided by 5? They are what? Consecutive terms. Doesn't have to be the first and the second as long as they're giving you consecutive terms. You got me? Make sense?
Okay. That's my r. So I'm going to go to my formula now, a to the 1 over 1 minus r, and I'm going to plug in a to the 1, which is what? 5 over 1 minus r, which is 1 minus 1/5. 1 minus 1/5 is 4/5, and that ends up being 25 over 4.
The reason I can do infinite geometric series when r is less than 1 is because instead of getting bigger, the number is getting infinitely smaller. So eventually that will become so close to what? 0 that it's not like adding anything at all. Seem good?
Is there any part of what we talked about today that is incomprehensible and needs to be re-explained? All right, so let me shut this off.